We are going to wrap up solving quadratics, and we're going to still be using the quadratic formula, but we're going to talk about leaving radicals in a simplified form and not changing them to a decimal. So that's what we're doing today. So radical is the same thing as a square root. Call it a radical sign. And when we're simplifying radicals, you may have seen this before in 8th grade, we're basically doing prime factorization. So I'm going to take 80 and I'm going to split it into two factors of 80, and I'm going to use 8 and 10. And you probably remember when you do, wow, I just forgot the word, prime factorization, it doesn't matter which two factors you start with, you end up, when you're finished, at the same place. So I have 4 and 2 and 5 and 2, and 4 changes to 2 and 2. So if I wanted to, I could use the square root of 2 times 2 times 2 times 5 times 2. And that's the same thing as 80. So if you think about what a square root is, you're taking a number that's squared and you're finding the square root. So I could also write this like this: 2 squared times 2 squared times 5. Since I have 4 2's, I can pair them up and put squared. And if I take the square root of 2 squared, that's just going to be 2, which would be the same thing as taking the square root of 4. I guess I could also write it like this: 4 times 4 times 5. Square root of 4 is 2, and the square root of this 4 is 2. So I'm going to end up with 2 times 2 times the square root of 5, which is 4 times the square root of 5, which would be my answer. So I've simplified my radical, my square root, but it's not a perfect square, so I end up with a remainder underneath the radical sign. If it was a perfect square, there wouldn't be anything left under the radical sign and it would be gone. So let's try 56, and hopefully you're going to start seeing a pattern and you're not going to need to go as far down your prime factorization, because you're going to go, oh, it's a 4. 4 is great because I know it's a perfect square. Anything that's a perfect square can go under your radical sign because you're going to square root it, it's going to come out, and there won't be a remainder. So let's do 56. If I factor it, I have 8 times 7. 7 is a prime number. 4 times 2. 4 is a perfect square. So I'm going to rewrite my 56 as 4 times 2 times 7. This is the only number that is a perfect square. The 2 and the 7 aren't perfect squares, and there's not factors in them because they're both prime numbers. So I'm going to take the square root of 4, which is 2, and I'm going to leave my 2 and my 7 inside. So I'm going to end up with 2 times the square root of 14. 14 doesn't have any perfect squares in it as factors, so I'm finished. Okay, let's do 245. I know I can divide by 5. 5 goes into 24 4 times. 4 left over, 45. 5 goes into 45 9 times. Oh, look, a perfect square. I'm done. I'm not going to do any more work, because if I have the square root of 49 times 5, and I can take the square root of 49, which is 7, then I end up with 7 times the square root of 5. That's what I'm talking about. So I could have done 7 and 7, but when I saw 49 and I know it was a perfect square, I could put it under my radical sign. So that's all we're doing, but we're going to do it as part of our quadratic equation now. So how does simplifying radicals apply to solving equations using the quadratic form? Well, we don't use decimals. And we can simplify our discriminant when we square root it. It's another way to put your answer, leaving it simplified, and you will see that when you get to Algebra 2, possibly in geometry, I'm not sure. So let's practice doing that. Okay, so number 5. A is equal to 8, B is equal to -3, C is equal to -9, and our quadratic equation says x is equal to -b, which is 3, okay, I wrote it down wrong. So it's -b, so it's going to be 3, plus or minus the square root of b squared, which is 3 squared, it's -3 squared, plus 4 times 8 times -9, all divided by 2 times 8. You can actually put this in the, well, you can't really. You can put this in the calculator, but you can't do the plus or minuses in your calculator. So it doesn't really work to put the whole thing in there. But let's think about what we could put in the calculator. You could put everything inside your square root in the calculator. So 3 plus or minus the square root of 9 plus 4 times 8 times 9 is 288. And all that's divided by 16. So I have x equals 3 plus or minus the square root of 297 divided by 16. And 297 is 9 times, that's 18 when you add them together. So that's 9 times, I'm looking at my paper, but it's not helping me. 9 times 33. Yep, 9 times 33. So 33 is 3 times 11, and neither one of those are going to be perfect squares. So I take what I have, and I'm going to make it x equals 3 plus or minus, taking the square root of 9, leaving my 33 inside, divided by 16. And this is how we're going to leave our answer. So we're kind of doing less work because we're not using decimals, but we're looking for perfect square factors when we're doing our quadratic equation. Okay, number 6, I need to solve for everything on the left and make it equal to 0. So if I've got 6x squared minus 12x plus 3 equals 0. So a equals 6, b equals -12, c equals 3, x is equal to 12. Oh, I have a common factor. Let's erase all that and start over with our common factor. I know, groan, grumble, whatever. Okay, let's go back. Did I pick my color? All right, so I'm going to divide everything by 3. So I have 2x squared, much easier to work with, minus 4x plus 1 equals 0. So a equals 2, b equals -4, c equals 1, x equals 4 plus or minus the square root of 16 is b squared plus 2 times 2 times 1. B squared minus 4, that's a minus sign. I changed it in my other one because I had a negative. Okay. divided by 4. So I have x equals 4 plus or minus 16 minus 4 is 12 over 4. X equals 4 plus or minus 12 has 4 times 3, which means I've got the square root of 4 times 3. I can take the square root of 4, so I end up with x equals 4 plus or minus 2, which is the square root of 4, times the square root of 3 divided by 4. And we're not going to do it so much right now, but I could, since I'm dividing my 4 by this number and by this number, I could change it to, like, simplify. This turns into a 1, and this turns into a 1/2. So I could write x equals 1 plus or minus 1/2 times the square root of 3. And if that doesn't make sense to you, we'll talk about it tomorrow. And if it still doesn't make sense to you, we might not worry about it. Okay, number 7. I have 10x squared minus 5x minus 25. Greatest common factor, 5. 2x squared minus x minus 5. A equals 2, B equals -1, C equals -5. So x is equal to negative b, which is 1, plus or minus the square root of b squared minus 4 times 2 times -5 divided by 2 times 2. X equals 1 plus or minus the square root of 1 plus 4 times 2, 8 times 5 is 40. So I'm going to end up with x equals 1 plus or minus the square root of 41. And 41 does not have any factors. It's a prime number. Double checking, double checking, double checking. Yep. So we can't do anything else with that. So this is in fact our answer, and we're going to leave it just like that. So instead of putting our square root in the calculator and getting a decimal, we're leaving it as the simplest, it's called simplified square root. And once we do that, we're done with our problem. Which of course will make you crazy, because as soon as we get to number 8, they ask us to start rounding. But we're going to work it out, and then we'll see what happens. Okay, so here's my function. And we're looking for how long it takes for the scaffolding to hit the ground. So if my scaffolding hits the ground, the height is 0. So I have -16t squared plus 50 equals 0. And I can divide by 2. And I get -8t squared plus 25 equals 0. So A is -8, B is 0, and C is 25. So when B is 0, I have x equals -b plus or minus the square root of 0 minus 4 times 8 times 25. 8's negative, so it changes to plus, all divided by -16. So I don't need to worry about my 0. I end up with x equals the square root of 4 times 8 times 25 is, 4 times 25 is 100, so it's 800, divided by -16. Oops, but it's plus or minus. So 800, it's going to be 8 times 100, which I just had, right? So I'm going to have 8, no I'm not, I'm going to have 4 times 2, which is 8, times 100 over -16. And I like that because this is the only thing that's going to be left. My square root of 4 is 2 times 10 times the square root of 2 all over negative 16. 2 times 10 is 20. So it's either going to be x equals 20 times the square root of 2 over negative 16, or x equals negative 20 square root of 2 over negative 16. So it's not going to be this one because that's going to be a negative number. If I have two negatives, they change to a positive. So let's think about 20 divided by 16 is, or I'm going to find a common factor, which is going to be 4. So that's going to be 4, that's going to be 5. So I have 5 over 4, which is a little more than 1. .25, and I have a square root of 10, which is 1 point something, square root of 2, which is going to leave me somewhere around B for my answer. The other ones are so far off, C and D, not even possible. So there you have it. Last one. Okay, so we're going to assume that if the squirrel starts at 60, by the time it drops 60, it's going to be at 0. So we're going to have negative 16t squared plus 60 equals 0. We're going to find a common factor. 4. Negative 4t squared plus 15. A equals negative 4. B equals 0. C equals 15. X equals plus or minus, I'm not even going to worry about my 0, square root of 0 minus 4 times 15 times negative 4 over negative 2 times 4. So I have x equals, I put an equal sign right there, but x equals plus or minus the square root of 4 times 15 is 60, and 60 times 4 is 240. Over negative 8. So 240 is 24 times 10, which is 8 times 3 times 5 times 2, 4 times 2 times 3 times 5 times 2. So I've got this one, and I've got these guys. So I have x equals plus or minus square root of 4 times 4 times 3 times 5. So I can take the square root of those, divided by negative 8. So I'm going to take the square root of those. That's not what I wanted. And I end up with x equals plus or minus 4 times the square root of 15 over negative 8. And I put my 3 and my 5 back together to make 15. And my square root of 4 and square root of 4 is 2 times 2, which is back to 4. So I am going to divide. So I have x equals plus or minus the square root of 15 over negative 2. Again, I can have x equals square root of 15 over negative 2, or I can have x equals negative square root of 15 over negative 2. This one will be negative. This one will be positive. And think about square root of 16 is 4. And the square root of 15 is going to be really close to 4 over 2, which is 2 seconds. So it's going to be just a little less than 2 seconds. And I'm using what I know about my perfect squares to say that the square root of 15 is really close to the square root of 16, which is 4. So 2 seconds is going to be my answer, about. Alrighty, so I hope you took notes as far as which parts you didn't understand, so we can talk about it on tomorrow.